Hello and welcome everyone. Let's begin Istio. Microservices. What are microservices? Over the years, there have been enormous successful attempts to break the monolithic systems into one or more adapted and flexible microservices, with each microservice performing a specific functionality of the business. The newly created microservices communicate with each other to support and mimic or even improve the existing functionality of the parent system by a huge degree. As you can see here, I have a monolithic system with its user interface which contains multiple business logic. It has own DB storage, and over the years of experiments, we have broken it down to two microservices, just for example. After breaking the monolithic system into multiple microservices, it obviously comes with multiple perks like automation of one microservice. If we want to do, we can achieve it easily, and we have improved scalability. We don't have to worry about impact on the other service, as it is not a part of a monolithic system anymore. We can manage it easily. We have the independence, and the system is more agile, and we can do a fast delivery and deployment. Like, we do not have to be dependent on one system to be impacted, or to get to a halt or to a stop a system, for example. Well, any advancement does not come without its own inherent problems, because as the number of microservices increase, its complications increases with it, and its ability to communicate within each other requires more and more complex structure. As we can see here, we have a microservice 1, microservice 2, and microservice 3. These three microservices are communicating with each other properly, but as they communicate, we don't have any idea or any means to know if there is something wrong between one microservice to another, or if their service is secure. Because if someone tries to get into the microservice structure, and if they get in, we don't know what they can do or what they can achieve with our service. So that is the problems with microservices. We have broken our monolithic system into multiple systems, thinking that okay, we can achieve greater things, but we have security issue. We don't know if the communication between one microservice to another is secure, like I showed you in the previous slide. Routing, if we want to route request from one microservice to another, that's very good in case of one or two microservices. But let's say if we have thousands of microservices, how we can achieve that? And if our communication gives error from one microservice to another, there is no way to log that or handle that. We get These errors are very hard to find or even understand, or their security. And if someone has gotten into the microservice, and if they are trying to do something nasty, our service is gone. We can't actually protect it. There are lots of issues with microservice structure, with one microservice not being able to communicate with another, or security issue or whatever. But there is a way to handle that. That can be handled using a service mesh. Service mesh is a structure that lies with our microservices, that uh, enables them to communicate with each other properly. We can say that on the top of layer or below the layer of the microservice, there lies our service mesh. If we deploy it, and it can control the traffic going from one microservice to another, or another to third to fourth, or fourth to fifth, or fifth to one, or whatever. And as we are discussing Istio is one such powerful tool that not only provides the communication between two microservices but also provides a lot of functionality which we'll see later on. And these services do not only protect the microservices, vis-a-vis the cluster also gets protected by the application of the service mesh. So now let us see how service mesh fits with our microservices. And here, when we say microservices, will discuss the microservices applied with Kubernetes cluster. So now let us assume we have three microservices applied. It shows the jumping. So microservice 1, 2, and 3. These three microservices under normal circumstances would communicate with each other and work properly. But now we have something called a service mesh. This diagram shows the logical application of the service mesh with the Kubernetes cluster, as a thought that this is how the service mesh works. So now let's say if someone sends a request to microservice 1, that request will not go to microservice 1 directly. That request will be first intercepted by the service mesh, and the service mesh would send the request to microservice 1. So now what's the point of the service mesh if the request has to be sent to microservice 1 directly? So now microservice do not receive the signal directly from the service mesh, otherwise it would be just a postman. But in this case, the service mesh can apply something called mesh logic. That mesh logic has the ability to manipulate the signal traveling from service mesh to the microservice. It can record its time. It can check if that signal should be received by microservice 1 or not. It can implement the response time. It can do multiple things that earlier microservice systems could not do. So once microservice 1 has received the request, it would send its response. That response would again be intercepted by the service mesh. Let's say in earlier version the response was intended for microservice 2. So in our case, microservice 1 still thinks that, hey, I'm sending a response, or I'm sending a forward signal to microservice 2, and microservice 2 still thinks that, okay, I am to receive a response from microservice 1, but it has been intercepted by the service mesh. And the service mesh again, it implements certain logic. It checks whether microservice 2 is eligible. It checks if the signal is required to be sent to microservice 2. All these applications can be applied with mesh logic, and will be controlled that should be controlled by the service mesh. So in our case, the response received from microservice 1 has been forwarded to microservice 2. Microservice 2 does its functionality, or whatever the functionality has been assigned to the service, and it sends the response back to the service mesh. Well, it again thinks that it is sending the response to the requester, but no, it sends the response to the service mesh, and service mesh forwards that request to somewhere else. So now let's say if microservice 1 wants to communicate with microservice 3, it again goes through the same method. There is no direct communication now. Microservice 1 will send a request to service mesh. That service mesh, and let's also assume that there is a requirement from microservice 2 also, which means microservice 1 wants to send a signal or receive a response from microservice 3, which requires microservice 2 also involved. So the signal or the request received from microservice 1 would travel to microservice 2. Microservice 2 would send a response. That response would go to microservice 3. Microservice 3 would do its own service manipulation of the data or whatever is required, whatever has been configured within it. It will send the response, and that response will be sent back to microservice 1. Within all these microservices, they still under impression that they are communicating with each other, but it's a service mesh, and the service mesh captures a lot of data. We can term it as a telemetry. In terms of Istio, we can term it as a telemetry, and these telemetry I'll show you later how we can use for our benefit. So now, what is Istio? Istio is an open source service mesh, a service networking layer that provides a transparent and language independent way to flexibly and easily automate application network functions. In easy words, it provides more efficient and simple ways to make a connection between two services and to bring a lot of added perks with it, like Prometheus, Grafana, etc. So what are Istio components? Istio has two components, data plane and control plane. Data plane is a plane that contains set of proxies which are used to enable communication between services. These proxies in this layer are high performing intelligent proxies. They are also called envoy. And the control plane is the brain of Istio. It provisions and controls the requirement of data plane. So now let's see what is the architecture of Istio with microservices. For our example, we will consider the two microservices, microservice 1 and microservice 2, with its pod containing one container each, which should be the ideal case. We do not apply multiple containers. And these pods are these microservices, as we can say, are communicating with each other properly with ingress traffic coming into container 1, or better say microservice 1. The response is going to microservice 2, and it's going out of the microservice 2 as egress traffic. This is the usual scenario that we have often seen. But in case of Istio, let's apply some Istio into it. Yeah. You see, now create the Istio mesh. You see the Istio getting its jump. And when we apply Istio, it by default, at the time of creating the application itself, injects a sidecar into each pod of the microservice that are being applied as a part of the application itself. You see, these sidecars are proxy containers. Yeah. In earlier versions of Istio, we used to call them proxy containers. Now we call them envoy. So just like previous scenario, when the ingress traffic was traveling directly from microservice 1 to microservice 2, now it will be intercepted by the envoy container, and that envoy container will or may apply some logic depending upon its mesh configuration, and then it will send the request to container 1. Once it sends the request to container 1, it is bound to receive a response. That response may be good or bad. That will be decided by the configuration of the envoy and the mesh logic. It then forwards that request as a response to microservice 2. Microservice 2 intercepts it as a request. Without the Istio configuration, microservice 2 will receive the signal into its container, will perform its processing, and send it forward. But we have Envoy sitting within the pod with container 2 of microservice 2. The Envoy will intercept the signal, or better say the request, and it will do its own manipulation if configured, and it will forward that request to container 2. Further, it will receive the response from container 2, and it will perform all the checks. We can see all those on Prometheus or Grafana or Kiali. Kiali is one best way to see how our load is performing. We can even control the load that goes from one microservice to another using the Envoy proxies. So this is how the signal will go from one microservice to another. Okay, this is called mesh traffic. Now we have perfectly configured Istio mesh traffic. And here comes the best part. Yeah, since this part controls the traffic that comes from outside or anywhere, or any request to and from the microservices and even out of the microservices. In other words, it controls the data. So that's why it's called the data plane, just like we discussed in the previous slide. The Istio has two components, data plane and control plane. So it is called the data plane. And for every data plane in Istio, wherever we install, we need a brain. Its brain is called control plane, and the components of control plane are istioid and istiod or istioid, whatever we feel free to call it. And istioid is composed of pilot, citadel, and gallery. These things will be discussed on later slides, or on more practical basis. And Istioid, pilot, citadel, gallery, all these comprise and create one thing called the control plane. And the control plane basically controls everything on the data plane. Thank you.